4, exploring C, structures. Okay, so structures are going to show up in this lab for the first time, lab exercise. You'll be using structures. There are a couple other objects that you'll use, and I'll just talk about them in passing. I didn't do a full intro to them. But this is new, so I wanted to talk about them a little bit. C structures are used to group information that belongs together. The quintessential example is the tuple. Coordinates that define a point, right? So a double would be a 2-tuple. Triple would be a 3-tuple. And an n-tuple is a grouping of n things together. Okay. The following example shows some of the syntax. So we'll make a little main C function. This is all executable, by the way. So if you just like copy and pasted this in, you should be able to run this on virtually any C compiler, and it should work just fine. So main, first we'll declare a point to be, so we'll say struct point. So we're declaring point to be a struct or a structure. And we see these curly braces open and close. So things that are going to be inside of a point structure are a double, we'll call that double X, and another double, we'll call it double Y. You know, like XY coordinates. Yeah, I know. Yeah. Okay, so now we've just declared them, and now we want to actually declare an instance of a struct point. So we're going to say, okay, this pt1, point 1, we'll define as being, it's a point, which is a struct, and it has instance 1.2, 4.5 values. So x is going to be 1.2, y is going to be 4.5. We'll save that point. Could also save another point called point 2, another instance, which we have just declared here, but we haven't given any values to. So here, when I declared point 1, I gave it values, gave it default values. When I declared point 2, I didn't give it any values, so we know that point 2 is going to be a point, but we don't know what x and y are yet. Okay? So point 2.x I can assign to the x coordinate, if you will, of point 2 as being 2 times point 1.x. So I will assign that value. So I'll take point 1, take out the x value, multiply it by 2, and assign that to point 2.x. Point 2.y, I will say, is 3 times point 1.y. Okay. Then I want to print out point 2. So what is point 2? I'll print it out in a nice format string here with point 2.x, point 2.y as being the two numbers that will be printed out. Two double numbers will be printed out, and we get returned in the console. Point 2 equals 2.4, 13.5, which, if my math is right in my head, is 2 times 1.2 and 3 times 4.5. So makes sense. Okay. The first declaration, struct point, shows that two double types of members that are grouped into a structure, double types are grouped into a structure with structure tag point. The structure tag allows us to reuse this template for further structure declarations, as with point 1 and point 2, two instances of a point. Although in this case, the two members are of the same type, double, they need not be. For instance, an instance of a structure can be assigned at declaration, as with point 1, or can be assigned after declaration, as with point 2. The members of an instance are accessed and written to via the name defined in the initial declaration, as in point2.x and point2.y. Would you mind shutting that door for me? Thank you. C structures can also be nested. For instance, a line segment can be defined by 2 points, as shown in the following snippet, which could be interpolated into the previous main function. So we could say a segment is a struct of point structs, where the first one is point 1 and the other one is point 2. And we could call, we could declare the first one to be seg1. So seg1.point1 equals point 1, seg1.point2 equals point 2. And now we'll print the segments. So seg1 is from this point, from this x, y, so 0.1x, 0.1y, to 0.2x, 0.2y. So seg1.point1.x goes here, seg1.point1.y goes here, seg1.point2.x goes here, seg1.point2.y goes here, and it prints out. Note that we can overload the names of structure members, such as point1 and x, without conflict. Furthermore, the syntax that declares seg1 can be used to declare further segments. A function can be passed as an argument, a structure, or a pointer to it, or each of its members separately. Similarly, a function can return structures in any of these ways. Note that structure tags declared in main are available to other functions. So that's important to know. The structures themselves are global in that way. So, yeah. We're going to see structures in the lab exercise, so I don't want them to freak you guys out too much. Okay, any questions on structures?
So would there be a point to declaring a static structure then? Or can you even do that?
Yeah, you could, in the sense that, so say you were in some function that you're going to call multiple times. You could create one that's static so that next time you came back to that function, it would still have its old value. So just like we've used static variables before, like ints, you could do a static struct that would have the value. So the struct form will be there at the lower levels from main, but the individual values wouldn't be unless you declared it to be a static variable. So it would keep that variable around. So that would be the difference between those two. So there would be a point to if you wanted to do that. If you're like, I want to, every time I call this function, I want to do something to the same struct, you could declare it static so that it would always be the same one. Yeah. Okay. So that's structs.